There we go. Good morning. My name is Mike Wilson with ibpsa-usa. Today we have Patrick Pease presenting cove.tool's new product called loadmodeling.tool. We're excited to have cove.tool as a sponsor for ibpsa-usa, and we do appreciate their support. And now I'm going to hand this off to Patrick with cove.tool. Patrick?
Thanks. So yeah, as Mike said, I'm going to present our new tool called loadmodeling.tool. We're going to go through just a few slides to introduce the product itself, and then go straight into a live demo kind of the application itself. So let me share my screen and we can kind of get going. All right, so very quickly, just a quick agenda. Going to go through very quick introductions, an overview of what loadmodeling.tool is, kind of what the implementation is, how is it running, some of the integrations that we have with it. There's quite a few. A little bit about the purposes and goals, and then get on to a demo of the actual tool on the platform. So first, just brief introduction to myself. My name is Patrick Pease. I'm the Mechanical Engineering Director at cove.tool. I've a bachelor's degree and a master's degree from Boston University. About 10 years of experience in the AEC, mostly from actually Europe, both in Boston and Dublin, Ireland. And I hold a PE in Massachusetts, along with membership of ASHRAE, ibpsa, and MCIBSE. Of course, I'm not by far the only person that worked on this new tool. Here's the amazing team at cove.tool that kind of put this together. A lot of software was written for this tool, a lot of research done, a lot of integration along both on our side and then with NREL support as well. So a lot of kind of great work went into creating this tool that I'm sharing today. And so kind of right off the bat, what is loadmodeling.tool? It's kind of exactly in the name. So it's a mechanical load calculation system sizing tool, and it's based on the Energy Plus simulation engine. So all the calculations that we're doing is going through Energy Plus. That's the engine we're using. It is a web. Sorry about that. So it is a web native service, and this gives us a lot of advantages around speed. It's very quick to run models on the cloud because we can ramp on our backend servers to control run times, keep those down. It also allows a lot of access. So the model is now accessible by URL. Anywhere you have an internet connection, you can get access to the model. You can get access to the results, the inputs, all that important information. So a lot of advantages from just being web-based. It also integrates with the wider cove.tool platform. So the daylight analysis that we do, the early stage modeling that happens, the parametric optimization, all of that is connected and integrated with the load modeling, because we're really trying to create a seamless transition from the early stage modeling that we as cove.tool want people to do to improve their buildings and save energy and carbon, and then the key task of load modeling. So we're trying to connect all those and really make it easy for everyone to do. And then finally, just another connection, of course, that connection to BIM. So whether it be a Revit model, a SketchUp model, Rhino model, or a few others, we can bring in that geometry to do our analysis in, or we can actually draw all that geometry for the whole model just live in a browser. So if you didn't have a building to start with, you can go straight into cove.tool and start modeling. So a bit about the implementation. So we're currently running Energy Plus version 9.3. We are going to upgrade, of course, to I think 9.4. Just 9.5 just came out a few weeks ago. So we'll be updating to that. We're in OpenStudio version 3.1, SDK 3.0.1, and everything that we're doing is running on the Amazon Web Service. So very secure, very robust, and very scalable, which is one of the keys to the model of being able to do stuff in the cloud, the scalability of it. One thing that we really like about integrating with OpenStudio and Energy Plus is that at any given time you can download that OpenStudio file, you can download that Energy Plus file, so you have full complete access to the model, and really. Kind of in this graphic that we're showing, loadmodeling.tool is almost a wrapper around those services. So where have the interface to collect all the inputs, collect geometry, correct schedules, all that kind of stuff. That's going to pass into the OpenStudio. It's going to pass in MCIBSE, and then we're going to see all the results that we can action again via loadmodeling.tool. So a few disadvantages of OpenStudio. I'm sure a lot of you have used OpenStudio and are very familiar with it. Some key advantages, of course, it's open source. Some awesome things about that being open source is it's very automatable. And this is critical for, I'm going to call them quote unquote everyday users, the people that perhaps haven't typically run energy models on their projects, typically do very simplified load modeling because they're just doing your typical office blocks, apartment blocks, and just trying to get them done very quickly and at very low cost. So we're going to call those kind of everyday users, and we can automate a lot of steps for them, kind of thanks to some of the bones of OpenStudio. At the same time, it has almost unlimited customization for advanced users. So when we're doing those mega really cool projects, we can customize the systems, we can customize geometry and constructions and all these things within the same platform and get that huge level of detail that some people are going to need on their particular projects. So in that way, it kind of reaches both these users and is able to meet their needs. In addition, there's already the active development of it, thanks to Department of Energy and NREL, and then the great community, which of course ibpsa is part of, and help connecting that of people using OpenStudio, developing for it, and sharing information about it. The other kind of critical piece of OpenStudio, and kind of goes back to I'm going to call them the everyday users, is it is a graphical user interface, and this makes it much easier and approachable for non-experts to use. So that is why we've integrated with it instead of going straight to MCIBSE, because by having OpenStudio, we do everything on our end anyway, but we always want to give the users the ability to look at it in a more open source way if they desire, hence the graphical user interface of OpenStudio. And now, of course, OpenStudio is running the MCIBSE engine, and there's a huge number of advantages to the MCIBSE engine itself. Again, it's open source. Kind of nicely, especially in AEC, because software often isn't, is it's cross-platform. It runs on Windows, Linux, and Mac if you need it to. It is funded by the US DOE, and it's it's been trusted and used since it came out in 1997. So it's a very good engine to have backing us. It has the advanced functionality for HVAC system configuration with its loops and such, and that's critical for sustainable design, because HVAC systems are getting more complicated the less energy they're trying to use, and that means we need that ability as we build out our tool, because we're going to hope and point people in the right direction of this. We can save energy if we use this system. We're going to need to be able to model that very simply for them as well, or else the paybacks are going to be hard to see. It's a robust heat balance based solution. Again, highly customizable when it comes to simulation controls. A lot of that can be automated again for those everyday type users, and then users that need and want to be able to get into the exact calculation methodologies, the exact time steps, all of that stuff that's open and available to them. And through load modeling, it's open and available, so they can edit that. And then finally, it's a simultaneous solution engine. So it's solving for room loads, zone loads, system loads, plan loads, all at the same time. So it gets you the correct right size systems through the engine itself. So a bit about how we're, again, integrating with OpenStudio. The primary method, of course, is through OpenStudio measures. And if you haven't kind of used measures before, they're very handy kind of tool set within OpenStudio itself. Essentially, it's a script or an instruction that we can send to the energy model to do something over and over again. Very simple graphic. We have a model, we do something with it with a OpenStudio measure, and we get that model but modified on the other side. And that's kind of what we're doing with loadmodeling.tool. We start with a seed file, which is going to be our geometry, and then we push through all these modifications. So if we changed every single template in every room of the building, we just simply modify that. If we change our constructions, we can modify that. All that stuff is just modifiable, repeatable, via these OpenStudio measures that we've written. And there's been almost, I had to look at this, almost 250,000 lines of code have kind of gone into the app as a whole. So quite a bit of coding has gone into it. Just a bit more about measures themselves. They are written in Ruby. So if you're big on coding and you want to write some Ruby, you can definitely get your teeth into some OpenStudio measures. And for this particular implementation, we have just fewer than 10 custom measures that we need. And that's because we're doing a lot of that data integration kind of on the loadmodeling.tool side. So a lot of the information's coming together, it's being stored kind of on the interface and then sent in kind of larger chunks via the measures to OpenStudio. So a bit about kind of a longer list of integrations. So loadmodeling.tool, which we're going to get to, runs on Energy Plus. The graphical interface that we have to handle geometry, that's also web native. That's actually 3.js. So that's an environment purely within your browser. You can draw, you can edit, you can modify, you can assign things like constructions, etc. And we'll go through all this when I go to the live demo. And it also integrates with our import plugins within cove.tool. So you can import geometry from Revit, SketchUp, Rhino, AutoCAD, Blender, BIM, a few others. So that'll get you geometry from wherever it lives when you start your project to where we need it to be for us to do analysis, mainly drawing.tool. A big part of drawing.tool that isn't, unfortunately, visual really in any way is the room finder. And the room finder is essentially a bunch of automation we've baked right in to close geometry for us. So a big challenge with Revit models and really any model in particular, trying to convert it to a BEM, a building energy model, is closing that geometry. And so the cove.tool approach is we don't require the Revit model or SketchUp model, what have you, to be closed. We don't require there to be rooms or spaces created. What we're going to do is take in the geometry, use this automation to heal or close that geometry. Basically, if we find a wall that's within a foot or so, maybe 6 inches of another wall, we're going to assume those are supposed to connect, and we'll heal that. And that closes geometry and creates rooms within the space. In this way, we can create our zones, which of course we need for energy modeling via OpenStudio and Energy Plus. So that's a big part of the automation that's happening in drawing.tool. Another great thing is all the geometry is dynamic. You can push, pull, delete, add, change sizes, add local shades, what have you, all within drawing.tool, and then send that to load modeling. So if you have edits you need to make, you can do it there, of course. And then the geometry plus the rooms is what's translated automatically into loadmodeling.tool. So we'll see later on, every single surface can have a unique performance. So you'll start with a very good starting point and can customize it from there. So a lot of great integration and customization there. The next thing that we have integrated is the energy codes. So in the base cove.tool application, we've done a lot of research and work already to automate energy codes based on location for projects. So if you have a project in California, we know that's following Title 24. We've already documented what's the minimum or R value allowed for roof for the energy code. That's in our database, and we can simply look it up. All that information is now actually integrated with drawing.tool and loadmodeling.tool, such that when you bring in a room, it has a roof, it'll have the right R value there. It'll have a floor, an internal floor. What's the correct U value for that? For the windows, what's my U value? What's my soil heat gain coefficient? And so when you draw either from scratch or you've imported a model, every surface will have this default value assigned to it. So you'll be pre-populated and kind of ready to, if you wanted to, just go straight to loads and say, well, what's the load if I just followed prescriptive minimum code for these assemblies. And of course, the goal of this, and really the intention, is to customize these. So say, I know I'm going to do a better roof. I know on my south facade, I'm going to do, better glass because I know I'll have more heat gain there. So you can make all those adjustments and send those, into the tool, so you can get the, exact detail loads that you'll need to have. And this is some of the things too. We hope that when you see the loads, you'll be able to make these decisions to say, oh, this room, the heating load was skyrocketing high because my glass was very poor performing. If I increase the performance of my glass, I can save some load, save some energy. And that's all the things we'll try and communicate with the tool. Some of the other integration with that, in fact, is back to that baseline energy model. So we will be running kind of a full, we'll call it a whole building energy model, 8760 model via Energy Plus in loadmodeling.tool. However, not every user, I'll go back to that kind of everyday user, kind of needs that or wants that. Not kind of right now, not every building even gets any energy model. And so our goal is, if users are using the tool to do that load modeling, we're going to always calibrate back to kind of the Cove tool baseline energy model that's super quick and super fast and gives people, good understanding of the EY, of the baseline, of the benchmarking, so they can make decisions quickly, kind of without even realizing they're doing that model. So to do that, we're actually taking that detailed, surface by surface performance and room by room, internal loads based on, the templates assigned. And we're going to translate into that baseline model that runs, super quickly on the cloud. So it'll always be available to, users, whether they've, thought to look at it or not. It'll be there kind of, begging them to check on their energy and, hopefully reduce it, because that's totally something that we're, trying to do. So a lot of translation from the detailed model back to that really simple, easy to use early stage model. Kind of one of the last integrations is, the managed teams. So I talked a bit about, getting things, off a C drive, so to speak. And because we are an online platform, multiple people can have access to it. So for example, perhaps, I made the model, I uploaded geometry, but then I want, someone else on my team to do most of the load modeling. I can invite that person to the team, say that's, my mechanical engineer. I can say, oh, can you do the load model for this project, on here? When that person's done, they can simply let me know via, just a chat. Hey, go check on the model, the results are there. And all I need to do is log in and I can see the results instantly. There's no files to move around. There's no reports whatsoever. It's always, the live active model. So we're moving more towards what you might call, like the BIM 360 approach of everyone's looking at the same model at the same time. It's always up to date. So a lot of the work there to get the information, created easier to use and easier to review. Because that's always a critical step with any, energy or load model. It needs to be reviewed by the correct people. Another thing we've integrated kind of straight into the tool is built-in information sharing and kind of, we'll call it storage and growth. So right off the bat, we have a function to save templates and schedules into either a personal or firm-wide library. And what this allows firms to do is create, the library or catalog of the templates that they use, every time they do a load model. So say they have a specific client and, their offices always have a specific schedule, a specific plug load. Maybe they do denser people, then is, the standard ASHRAE value that can be saved, assigned. And then the next time, an engineer starts a project, with that client, as the owner, they can pick from, that library and say, oh, I need to use these 5 schedule or these 5 templates, assign that to my building and run my load model. So that we can, learn from our past, projects, save that information to somewhere it's accessible so it can be used, again and again. And for that, you'll have, a personal library, so you could, have your own. Or again, saved to that firm-wide level. So say, now the firm is trying to, share that information more broadly of how we're doing, load models more correctly and more quickly every time. And it's a lot about, moving the knowledge, from someone's C drive where it's not accessible to, a web interface, a web platform where we can, have a look at it. You can share that with the junior engineers, say, these are the typical templates that we need to be using. You can explain why that is, and they'll always have access, to those templates or schedules. So that's baked right into the tool. One other thing that we added kind of right off the bat, because it's been hotly requested, is the ability to have custom weather files. So the custom weather file, kind of more importantly, allows us to design for extreme or simply future weather in our design. So climate change is happening, very apparent, this year and pretty much every year past. So the ability to design for those more extreme conditions is becoming more and more important, and that's integrated, directly into the tool for the load modeling. And so just before I get to the live demo, I just wanted to share a bit more about, why cove.tool has chosen to make, a load modeling tool. We've been focused on, early stage modeling in the past, daylight analysis, etc. And really, it comes down to our core mission, which is to reduce carbon from the built environment. That's what we're about at cove.tool. We're trying to reduce carbon both from emissions as long with, embodied carbon. So the first step, if our goal is a net zero building, is always to minimize the internal and external loads. So to help with that and assist teams to do that, very important task, we're creating this tool so we can run those loads, we can analyze those loads, and we can look to reduce them. We can say, what if we reduced these lighting values? If we had better lights, we'd save load, we save energy, we save all these good things, and drive the reduction in CO2 that way. The other one, and this is one I've kind of already hinted about, is to essentially run more energy models. So we all know not every project gets an energy model, but I'm going to hope we'll just say 95% of buildings, get a load model, because we got to know what to design, what size is the system's going to be. And by connecting that required task to a very desirable task of energy modeling and doing that very quickly and seamlessly, we're hoping that more and more buildings get even that early stage model done, so that people know how much energy is going to use and hopefully can make a decision to reduce the energy that is used. So again, connecting that required task with a task that will help reduce carbon in the built environment. And then kind of finally, one reason kind of on my side especially, is just to increase engineer happiness. Load modeling in the past is a difficult task. It can be difficult, time consuming, frustrating, all those adjectives that lead to grumpy people in the office. And we're hoping to alleviate that by making it user friendly, making it work the first time, making it well documented, and all those things that kind of increase the happiness of the engineers doing that, because we believe that a happier engineer can design a better building. So that's very important to us as well. So a quick rundown of what we're going to see today. So some of the current features, the room template manager, so touched on that already a bit, with being able to save to Affirm and personal libraries. We have a schedule manager, custom weather file, envelope performances, so the room by room results, which are all running, again, via Energy Plus. We have some of the exports, so everything's viewable on the web, but of course we know we need record copies of things, so we have some records that we can export out. And then this is actually just released a week and a day ago, and we're already planning the next phase coming out this fall. And that's going to be the main thing will be system sizing for air systems, mechanical plants. So there's a whole building loads, compare loads within the buildings, and then that whole building energy model, and that'll be coming next year. And that'll be able to do complete energy model from early stage to compliance within a single kind of online platform. And that's very much where this is going for us. And so yeah, there's just a summary there. So again, all this was released on the 16th. We'll be doing weekly updates of the application every week for the coming months. We'll have a phase 2 very soon, which will do systems, so AHU sizing, etc. Allow us to customize those as we need. And then again, if a series of weekly updates, leading up to that whole building or 8760 energy model, in 2022. And so that's really the end of the presentation portion. I'm going to go kind of just through a live demo now of the app, and then we'll get right to some questions I see popping in. So that's excellent. Just a bit about what we're going to look at. It's just a building I've drawn. It's about 40,000 square feet. It's imported from 2021. I think, yeah, there's 52 rooms in it. And the location is going to be Atlanta, Georgia. So the ASHRAE code is going to be 90.1, 2013. And so with that, I'll actually pull up the application and we can see what that looks like. So here's the cove.tool homepage. Many of you have likely seen that. I'll just jump straight into the tool. As you've seen cove.tool before, you've seen this screen. It's absolutely unchanged. We've defined some high-level things about our project. I've given it an extremely imaginative name of Demo Patrick. I've called it an office for this case, given it an address that's gotten me my energy code. And then what I did is I actually went straight into Revit and I uploaded my geometry. So here's my geometry within the drawing tool. And this all came straight in from Revit. I can pull up the Revit model so we can take a quick look. Of course, with the method that cove.tool is set up, we're only looking at surfaces. So these are the surfaces I've brought in for this particular model. And I haven't brought in rooms. I didn't require rooms to be created. I only need the surfaces. The room side of things we're going to handle via loadmodeling.tool. So this is the model I kind of drew and then sent into cove.tool. And I can do several things on it now. I'm going to switch to a 2D view. And let's look maybe at the third floor. And I can see, now I have my rooms. I've assigned a few names to them. I've assigned some templates. And I can actually see now too, well, where's each room? Where are my rooms and how big are they? I can visualize all that. I can check on all my constructions. So what's my roof all values in this case? I have an internal floor going straight in. I could change some window values as well if I want to increase the performance. One thing I've done in this particular case, if I go back to the 3D view, we'll see, on this roof, I've left it at R25. That's the standard roof value for the current energy code in Atlanta. But on this particular, this low roof here, I've actually updated that to R40. And so that should give me some energy savings and load savings for this longer, lower roof. And we'll see the impact of that actually in the baseline energy model when I go there in a few. Because what will happen is we're actually going to take the area weighted average of this roof plus this roof and pass that to the baseline, that super quick energy model. And that's some of the calibration that we're doing again of if I put in that detailed information to do my loads, because I have to do my loads, but I really wasn't interested in energy, we're going to pass it to the energy anyway, so we can see the impact and we can know a bit more about our building. So again, we have several rooms. We've assigned templates, names, numbers, all the typical things. There's the rooms for level 2. And once I've done that, I can send them. I can export. This will send it. Don't want to write this time. That'll send it to loadmodeling.tool, and also again to the baseline, to the 3D analysis if I wanted to look at it there as well. So going kind of straight to the end, the exciting bit here is the results for that project. So again, we have all the rooms we were looking at. I can select any one of them and I can see details about it. So I have my area, the number of people calculated, the level, the office, the systems will be kind of added soon, and that'll be noted. I get my high level cooling peak, got a high level heating peak. I get my airflows, supply air, heating air, outside air, all of that's recorded. I get my room checks, and these are important to be checking for engineers to know am I close to the benchmark I was expecting for my cooling square foot per ton? Am I way off the mark? Am I surprisingly low? What have you? I need to see that check to know what's going on. And then if I click on any one of those, I get the detail that I want to see about the breakdown. So where's the load actually coming from? I can see here, it's a corner room. Solar radiation is quite a bit of the total load, and actually the external wall itself is actually quite a bit. So 15, 15 right there. I can also look at that as a percent. So there we've just switched it to percent. I can see it's actually 23%. So maybe I might look at increasing the R value of my wall to reduce the heat gain through it. So that's something I could do to reduce the load in that space. Similar for heating, in this case, I see infiltrations really driving my losses here. So I should look at the air tightness of my building, and I can know that right away once I run the load, and I can see what's going on. And so we can go through any of these rooms, look at those results very quickly. Another thing we can do, we could search. So if I just want to see the core, office core, I can find that quickly. And so the biggest room in my building, 44 people, see all the loads, and really enable kind of the person running the model and then the reviewer of the model to visualize that data quickly, see the information they care about, be able to make the call of, is this load looking correct? Do I want to dig in deeper and change something or not? If we did want to dig in deeper, we can export all the results to Excel. So there's download the Excel file, and the Excel gives us all the results just in bulk Excel format to allow us to do whatever analysis we wanted to do. So a quick summary of cooling peaks here and the airflows, and then the complete detailed of every single room, its area, time of peaks, all the way straight through kind of every variable you could think of to look at for that room printed out. So you can take a really deep dive into it. So that's one of the exports that we have right now. Of course, there'll be a PDF version of that coming very, very soon. And that'll also provide the same information if that's your preferred use case for how you want to look at the information. So taking a step back, if we go into settings, this is where, well, first of all, we can run the model again. If we made some changes, we can hit run. I can assign custom weather files. So here I have, sorry, let's go back. Here I have, the Atlanta airport weather file. That's kind of the default. And that's coming in, again, based on the location. So cove.tool is providing a weather file based on the location. If that's not the exact weather file we want to use, or if we want to use, a future, we could do that. In this case, I'm going to select, and I think I have one for Fulton County. So see, my building's actually slightly closer to this, more unique weather file. I can add that in, and we can upload the DDY, the EPW, and the stat file, because it'll read all that information. So the DDY being your design day data, we can add that in, and that'll update your sizing information. So I'll say okay. There's my files, and I can upload them. And not only is it now connected to my model, next time I run it, I get a readout of obviously what was the information in those one of my new design day values. So that's all provided here. Also on this screen, we do our heating and cooling factors. So these are global factors for safety, of course. We can edit those and then rerun and see the result of that. We can get the exact amount that has been oversized. That's in part of the Excel report. So we can visualize that and know how much we're oversizing and decide, yes or no, do I feel confident in my sizing or not? And then we can update currently the time step. And then here as well, once we have the air systems plugged in, we could turn those on and run the air system, and the air system will get you your AHU size, etc., all of that kind of good stuff. Kind of going a bit further back too, we can look at the rooms. And so the rooms is where we're looking at our room templates. So on the first screen on the left, these are all the templates that I have available to me. So these are a combination of the defaults with the program. the ones that we've saved currently to our firm, and then some personal templates that I've saved just for my own use. So the way I can do this is, say I wanted a different default template. Maybe I'm going to add an auditorium into my project. I can select auditorium. I can say this is my auditorium or auditorium version 2. I could change some things about it. Perhaps I'll have lower electrical load. Perhaps I have higher lighting load, what have you. I could edit the schedules of those. I could select a different schedule. I could even select down to the detail of, well, maybe my lighting here is maybe none of it's to the return air. That's a 0%. In my case, it's all in the space. It's all pendant lighting. We could assign that here. We can also do that for similar things like the electrical gain. And we can also simply just delete these loads if we didn't have any electrical gain. Say it was a void, what have you, we can delete them. We can adjust the airflow rates. So default would be 62.1 ventilation procedure. So what's my CFM per person? What is it per square foot? What's my infiltration rate? And this is infiltration of the envelope. So square foot of the envelope is the calculation that we're doing. And if it's a toilet, we could do a CFM per square foot of exhaust, etc. So all those things we can kind of edit. We could edit the cooling set points. So again, those are assigned via schedule. So maybe this is an auditorium, actually in my office block. So I can assign my office building, and we'll look at the schedules next. I can assign that to any of the rooms. So maybe a couple of my offices those are actually the auditorium. I can assign auditorium. I can see that's assigned now. And then of course I could save this. So the whole idea of saving back so I can use it on the next project. So maybe this is how I'm going to do all my auditoriums from now on. I can save that to my firm collection and then reuse it next time. And I can share with my other engineers to say, oh, this is the template we should be using. It has everything pre-populated for you to use. So that's a lot of what we can do on the templates themselves. Again, a lot of it with load modeling is just functions we have to have, but we've tried to build in some functions that are useful. For example, saving it back to custom firm-wide libraries and such. And we can, of course, start from scratch. So if you just wanted to start a custom template from nothing, we can do that and kind of start from there as well. Next thing I can show is the schedules. So the schedules, again, we need schedules to operate a load model and of course energy model. And so that's what we have here is a series of schedules. They operate in a similar fashion where we have a library with firm-wide, personal, or default schedules. And then each of these can be edited as we need to. Each schedule, of course, has a winter design day, has a summer design day. In this case, we have a default day. So if I didn't have any specific days, it's just this day. And then custom days, as we call them. So in this case, I have a weekend day for my office. We could do a specific day for every single day of the week as well, if I wanted to get to that level of detail, or whatever we needed to do to assign this specific schedule for that building. So if it was a school, I could do January to June. Is that when kids leave school? Not 100% sure. And then pick it up again in September to December and assign those summer months as well as specific schedule. So that's all possible via the schedules themselves. And again, for that, if we're creating a custom schedule, they are by type. And the types essentially allow us to filter that a bit more cleanly so we know what we're assigning to where. So if I'm creating a lighting schedule, it's a lighting type. I can only assign it to lighting and just keep things rather tidy in that respect as we kind of move through the tool. So again, we can customize pretty much anything. And then once we do, we would hit run model again, and we get the new results. The new results could be downloaded either as Excel or as the model itself. And let me switch just to OpenStudio quickly to show what that looks like. So when we download the file, we get a zip, and the zip will always include the weather file used, just for record, really. and then the IDF and the OSM. So again, we're always providing those files because we want kind of you, the user, to have access to your model. While we are web-based, we don't want it to be locked on the web in any way. It is kind of your information and model, and hence, the ability to download these files. So I'll just switch over here, and here's my instance of OpenStudio. I can go to my geometry and I can see my model. And so here it is, that model that we kind of started with in Revit. We kind of ran it through drawing.tool. We ran it in loadmodeling.tool to add in all of our detailed information. So if I look at constructions, I can see all those assigned. Actually, I use pretty much the standard default constructions on this one. I can look at my thermal zones and see where they all are. They're all assigned. If I go into, let's go to space types. I can see that space types have been created, and those space types have all the internal loads that we associate with them. And that's, a bunch of the information that's, passing through. And of course, allows us to run both on the cloud, and then of course, if you want to run locally here, you can totally do that as well. There we go. So yeah, if we look at loads, we can see that each office has been assigned the people gain, the lighting gain, the electrical gain, the schedules have been assigned, the activity has been assigned, the infiltration has been assigned, and all that's now here. That if I am an expert user, I can now go kind of really crazy in the weeds of editing this even further to do whatever I need to do. And kind of the roadmap, the game plan, is that anything you can do, via OpenStudio, you'll be able to do via loadmodeling.tool, so that you can, have it accessible in the cloud. You can make all that customization, but also do kind of the right customization. So we always have, guidance about, well, why would I want to do that? Is that, just adding complication? Am I saving energy if I do this? What's that actually mean, like, to my actual design? Is this something that, the engineers can design and a contractor can build that I'm modeling, and so forth. So a lot of stuff in that regard that we're going to build straight into the tool. And of course, with OpenStudio, you can get the full results already. So we could run and see those profiles, which will be connected up very, very soon, within the app itself, within loadmodeling.tool. So all that's available. And so just to show kind of the last thing I wanted to share is, of course, that back integration. So if I go to my baseline model, so here's my super quick baseline model for the project. So I did my load modeling, had to get that done, drew all my ductwork, what have you. And now I was like, oh, what is the energy in my building? I can see that it's calibrated back. And one way we can see that is, so right here, my roof fall value that we have modeled is 32.7, and that's the average of that low roof we had at 40 and that higher roof that we had at 25. So I didn't have to do any work to update that value and make this more accurate to my design. That's going to happen automatically, and I'll just be able to view the results and decide, yeah, okay, I'm doing close enough on the energy. But also the hope is that we come here and say, oh, how can I do even better? What's using energy? The equipment's using a lot. Is there anything I can do about that? Reduce energy further? Because that's always the goal of what we're doing. And so that's the runtime of the app. I'm going to go over to the chat now to see if there are any questions, and we can kind of run through those for the next few minutes before we disconnect. All right, I see a note from Mike. We have to stop at noon. That's no problem. So yeah, I can aim to wrap up at it'd be 2:58 on my clock. I'll track that. That's no problem. Custom weather file just for EPW, it doesn't include. Yeah, so first question, custom weather file just for EPW, it doesn't include DDY data. Yes, it does. You can upload that DDY file directly. And we are kind of looking at a way to allow users to edit those DDY information. So if you wanted to say, in this case, maybe I just want to do 95, 76 and just make it a much worse day. we're looking at allowing users to make that call directly, and they would edit the DDY information automatically for you. That's something we're exploring to open up for users. Next question we have, has cove.tool considered starting the process to make this method an officially approved manual J software for the residential world? Not yet, but definitely that's next on our roadmap, is seeing how we can make this an official tool for any kind of compliance level modeling. Because residential is definitely something that we're interested in, and you can already do kind of in the broader cove.tool. And it will be something that we look to kind of integrate in loadmodeling.tool for residential modeling loads as well. So that's a great question. It's definitely something we'll look into. All right, so next question. Actually, I can just share. I don't know if you all can see the chat, but I'll just share on the screen as well. Next from Michael here is, I feel like healing the GPXML is a big deal. I've tried many other modeling software that claim to easily and never have. So the key perhaps here is we're not actually using GPXML. We're bringing in the data kind of in our proprietary plugin method and using that to heal it directly kind of in 3GS. So it's a slightly different approach. And that does mean we're not taking things like, envelope performance that might be in, the Revit model in the GPXML, because we're going to start at the starting point of say, well, we probably haven't gotten there yet. We're going to assume that's wrong. Hence, we're reassigning that information, on the cove.tool side. So I'm happy to kind of get you in touch with some of our programmers that know much more about how the healing actually works. But it's not actually using GPXML. It's using just the geometrical information and then doing all the calculations on that to heal it up and close the data. So yeah, happy to kind of share more with you offline on that one. How do you attribute the rating component of internal loads properly given the time delay when the load may be expressed? So this is something that thankfully NG+ is kind of good at and known for. So we're relying on NG+ to do that. So we will have options to, open up the customization that NG+ has around doing that calculation. Right now we're running the defaults, which I can kind of share of how that's happening. But that's just a great function of NG+ itself that we're utilizing. That quick question there about block versus peak load. Right now we're looking at room level loads, so it'd be peak for all of those rooms. With the systems that we'll be adding very soon, we'll be looking at peak for the system, block for the system, and then once we block for the system, block for the room. So block will definitely be something that comes into the calculation. Let me just pull this up. Here it is. The next question I see, is there an option to control the boundary conditions of internal walls when they are connected to other walls? So currently the walls are defaulting to be adiabatic. The next approach will be to have them be adjacent to that adjacent zone. But we will open up kind of more options around what the adjacency is. So if they are adjacent to say it's an exposed floor, it's over a semi-conditioned space, what have you, we'll have some of those options available. Because again, that's a function that OpenStudio and NG+ has. So we'll have that integrated in. So we could say, this is over a semi-heated parking garage, this is not, etc. And have all that, information available. Let's see, I see another question from Lewis. If a model is imported, loads, and then she is run, and then new geometry has been imported, how many steps need to be redone to get new loads and results? Start from scratch. Yeah, so this is something that we're definitely working on improving even still. But essentially what will happen is, all the templates, all the schedules, that will all be saved. If, every single room has been deleted and they're all new and completely, in different locations, we are going to have to reassign stuff to those rooms. But if they are, in the same location, we'll save some of that data because we can do that with 3D space. We know where stuff was, we know where it is again, we can reassign. But really it becomes an assignment challenge of if geometry has changed a lot, teaching the software to reassign it correctly. So it is something that we're kind of working on. And it's certainly, I know it's a challenge from kind of my past life, as an engineer. One room's moved, somehow 500 feet, and trying to find it again by yourself, let alone with, an automation tool, can be difficult. So I see another question pop up. Along those lines, if it is a Revit surface only, then it's a complete clean start. Yeah, so if we're importing, from Revit and we delete the geometry we have, we'll recreate that geometry and reassign. But what we are looking for is, creating those rooms. So if we've created a room in the same spot, we'll reassign the same template that room in that same spot have, kind of in our geometric 3D space. We have, an XY coordinate. We can reassign the room template. But it can be complicated. There's no way for us to know just yet if that room is in fact still the same type. Maybe the architects put a toilet where there was an office, what have you. So all that has to be tracked back. But it is something that kind of the online platform and 3GS and all the kind of the tools we're using allows us to take a new approach at solving. So we're all looking at kind of tackling all those tasks. These are some really excellent questions. Thanks everyone for sharing. I know we do have to, sounds like a hard stop at just in a couple minutes. Any final questions from anyone on the call? It's been great to share the new tool with you. It is now live on our website. You can definitely talk to us and you can get a test going of it. It is also, of course, an active development. We develop very, very quickly. And every week this will look slightly different and even more improved. And we do rely on feedback from yourselves and many others on how we can best improve it, because we do want to make this the best tool possible. Because again, we just want to make it as easy as possible to reduce energy and reduce carbon in the built environment. So definitely something that we're hoping to do, and partner with IBPSA on as well, of how we can share that with everyone. So yeah, if there's no kind of final questions, I think we can kind of pause it there. Mike, thanks for hosting. This has been a great session. I hope it was really helpful for everyone that could join.
Sure thing. Patrick, would you drop your email into the chat? So
excellent. Yeah.
Those of us who might have questions later could reach out to you.
Yes, I'm going to add that right now for everyone.
And we'll include the link to the video to everyone that registered, as well as some of those chat questions in a follow-up. Thanks again to cove.tool. We appreciate your sponsorship and support here at IBPSA USA, and thanks to everyone for attending today. Once again, this video will be available on YouTube within 24 hours. All right, everybody, have a great day.
Have a great day, everyone.
Thanks.